About how many people do you think exist on this wonderful piece of planetary, third from the sun here? How many people you think are on this wonderful planet? Send me an email. Let me know how many people do you think exists on this wonderful, wonderful planet here. Ladies and gentlemen, welcome to Module 5, our number systems here. My name is Mr. Tandy at Tandy IT, Introduction to Networks. And I can't tell you how important, I mean, obviously all these modules are very, very important, but this one's especially important because it has a lot to do with this picture here. And you've seen this picture a lot when it comes to my modules. Again, I love bringing in the real world things that we do on a daily basis into this content because it just makes the learning a little bit deeper. But going back to this picture, this is a physical envelope with contents inside. It's encapsulated. It has the source address and it has where it is going. So you need to understand this concept, right? Going back to understanding this concept of where this goes. And if you have been paying attention to my video, where is this going to go? This is probably going to go to the post office, right? Where it's going to go out. But those post offices have addresses on there. There's a lot of addressing on there. And it deals with numbers, just like our wonderful letter here deals with numbers. It deals with numbers. And we have to understand these number systems because that's where our computers speak to each other. That's how our IoT devices on our planet, that's how they speak. They speak in numbers, ones and zeros, on or off, and other types of forms of operations here. So let's get into this. Our number systems, module 5. We're going to calculate numbers between decimal, binary, and hexadecimal systems. Binary numbers systems calculate numbers between decimal and binary systems. Hexadecimal number systems calculate numbers between decimal and hexadecimal systems. So buckle down. Let's get into the binary system. So IP version 4 address. That's what we all know that one very, very well. IP version 4. Binary numbering systems consist of ones and zeros. These are called bits. Okay, these are called bits. Decimal numbering systems consist of digits 0 through 9. A little bit different. We're going to get into that a little bit later. Hosts, servers, and network equipment using binary addressing to identify each other. Each address is made up of a string of 32 bits divided into 4 sections called octets. I'm going to show you a graphic of that here just shortly. Each octet contains 8 bits or bytes separated by a dot. And for each used by people, this dotted notation is converted into dotted decimal. So let's take a look at this. I'm going to put just a basic IP address up here. We're just going to put up here 192.168.1.1. Okay. So each one of these numbers, they represent 8 bits. Okay. So again, computer speaks in ones and zeros. We can't see the ones and zeros because that stuff happens in the background. But this is the translation of the ones and zeros. How does this translation happen? How do we get to this translation? So this first octet gets 8 bits. This gets 8 bits. This third octet gets 8 bits. And this fourth octet gets 8 bits, giving you a total of 32 bits. So that means an IP version 4 address, IPv4. Okay, sorry, my writing is off really bad. I apologize. I'm trying to do this on a computer. Your IPv4 version 4 address gives you 32 bits, right? Is a 32-bit system. But we're still not done. How do we even get to these numbers, right? How is it even possible for us to get to this 192? So watch this. And typically, right before I do any type of subnetting or if I do anything that deals with IP addresses or if I got to do any type of conversions, I am writing these numbers down here right away. And this is the bit stream down below. So watch this. We're going to put 128, 64, 32, The next number is going to be 16, 8, 4, 2, and 1. So this is one number, 2, 3, 4, 5, 6, 7, 8. So these are the 8 bits. These are the numbers that come up to equal to 8 bits. But we're still not done. How do we get to this 192? Essentially what you're going to do, you need to understand how to add these numbers up to equal this 192, and then that tells you which lights that are on. So let's put that in representation here. So I'm going to put the number 192 right here on the left-hand side here. Hopefully you guys see this here. And we're going to start with the first number, 128. We're going to go 192, and we're going to go minus 128. And I believe that is going to be a remainder of 64. So because we used 128, guess what, folks? That light is now on. It's going to get a 1. That light is on. Now we have a remainder of 64, which we have 64 available here. Therefore, that light is going to be on. 64 minus 64, that's going to get 0. So we don't see any zeros. So therefore, the remainder of the bit stream is going to be off. So the number 192, this is it in binary right here. Essentially by adding 128 plus 64 gives you 192, right? So you can kind of subtract it, add it. That's the way I like to do. I like to subtract it. It's a little bit easier for me sometimes, but you can also add it to make sure that the numbers go to where it needs to get to. So this is how the conversion happens. And you folks, you need to understand this. This is very, very important, because when we get later on in the videos with subnetting, you got to be able to divide the network line. Everything on the left is static. Everything on the right is dynamic. Those are the host bits. You got to be able to figure out what the network ID is, the broadcast ID, things of that nature. So this part is very, very important to understand. Very important to understand. So hopefully you guys were able to see that there. So the binary position notation, positional notation means that a digit represents different values depending upon the position. The digit occupies a sequence of numbers, so as you can see here. The decimal position notation system operates as shown in this table below. So we have the thousands, the hundreds, the tens, and the ones. Those are positional values. And then here we have position values down here at the bottom as well. So this is basically the translation of how that gets translated over. Now here's that bit stream that I was telling you about. And this is what I just got done. Let me erase this. This is what I just got done writing down right here. Right? The 128, 64, 32, 16, 8, 4, 2, and 1. That's what I just got done writing down there, right? So as you can see here, we took 128 plus 64, and that gives you the result of 192. That was that first number, the 192. This is the calculations on how they work. Now convert binary to decimal. Kind of just gave you a quick little rundown on that. This is essentially how, this is a good example of how they do this in binary. So this first number is, excuse me, the first 2 bits are on here. So that's 192. And then as you can see here, the second bits, excuse me, the second octet, see this light is on, off, on, off, on, off, 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 okay? And that's the number 168, and then we have 11 and 1. So keep in mind, and I'm going to go back to, let's see here, because what I like to do is I usually have my little sheet on me. And let me go back so we can understand this here. Give me 1 second here. Okay. So what I like to do is, as I explained earlier, I usually have my bit stream already written out. 64, 32, 16, 8, 4, 2, and 1. Okay, so I usually have this on a piece of paper. I have this on a dry erase board, whatever, right next to me. It's a lot easier. And every time, this usually stays, I don't ever erase this. every time I see any numbers, or if I see any numbers that need to get converted, just like, for example, let's just take the number 255. 255. What I'll do is I will start adding numbers, adding the ones and zeros on the top of here. That way I can get an easier representation on how these numbers are working out. Now, I will tell you right now, just from experience, if you were to add up every one of these numbers, it is going to equal 255. So essentially in binary, it's 1, 1, 1, 1, 1, 1, 1, 1, right? So that's everything there in binary. Now, if I wanted to do another number, what I would do is let me just get this out of the way here. There's another number that I need to do. Let's say I want to do the number 10 in binary. Okay. Well, right off the bat, by looking at this, I already know that the first 4 bits are going to be off. So I'm going to go 0, off, off, off. This is going to be on, off, plus another 2 is on, which is 10, and then off. So this is number in binary. So essentially, I leave this the same. I don't ever remove this when I'm doing my binary, but this is the part that changes a lot. This is how I can see the numbers in binary. And I just take the conversions and go from there. So just to kind of hopefully that may help you out there a little bit. All right, so let's move on here. All right. So as you can see here, the binary positional value is useful converting a data into decimal. Yep, absolutely. So this is a position value, right? Start in the 128 position, decimal number, octet, yes. If no, 0, absolutely. So if it doesn't get a number, it gets a 0. If it does, it gets a 1. So we just kind of went over that. This is a good way to, if you actually want to use this as an example, you can kind of draw your boxes this way. You can put the numbers down underneath. I like having the binary on top so I can look at the numbers. It just makes things a lot easier, smoother for me. So this is an example of converting a decimal to 168 to binary. So if you use the 128, yes, it gets a 1. That's what we just talked about. If you use 4, if this number is using 64, it gets a no. As you see, this is the binary notation. Again, I like these reversed. I like to have the binary numbers written up top. It's a little bit easier for me. So these are the different octets. All right, these are the different octets. All right, we have 8 bits for each, a total of 32 bits. And these are the numbers that are represented in binary. These are the bit streams that come in, right? These are the bit streams that come in, the ones and zeros, and this is the conversion as we see here. Hexadecimal number system, a little bit different from IP version 4. So let's take a look at it. So to understand IP version 6, we must be able to convert hexadecimal to decimal and vice versa. Take a look at these charts here. Let's take a look at these charts. We have our hexadecimal, which is 16 characters. Take note. Right in this area here, take note there. We'll talk about that here in a second. And then the decimal form is 0 through 15. So we have 16 numbers, 16 characters, and they both go hand in hand. And then we have the binary representation of what these look like. So we're going to get into that. Hexadecimal is base system numbering system using the digits 0 through 9 and letters A through F. Okay, and then it says at the bottom, hexadecimal is used to represent IP version 6 addresses and MAC addresses, that physical address. So let's really get into this. Let's take a look at this. So IP version 6 addresses are 128 bits. 128 bits. Remember, IP version 4 is 32 bits separated by octets. This figure shows a preferred method of writing out IP version 6 with X represent hexadecimal. Don't worry about that because I'm actually going to show you with my magic pen. Okay, so I have a wonderful IP version 6 address here. There is a lot going on here. You may be looking at this and you're probably like, can you like turn off the screen? Like, this is bad. I don't want to see any of this because this looks very, 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 very nerve-wracking and very hard to understand. So before we even get into this, let's just do a quick little recap. Okay, let's just remember how this works here. So remember, at IP version 4, let's go IP IPv4. Remember that. And let's just put a random number here. Let's go 10.10.4.5. Okay, so remember IP version 4 are separated by octets. Each one of these octets, they get 8 bits. That's IP version 4. Remember, and it gets 32 bits, right? So don't forget that. It gets 32 bits. Sorry, I got a busted 3 here. 32 bits, and that is a version. That's IP version 4. Now, note that with IPv4, they're separated by these periods. We like to call them dots in the IT world. Okay, by these dots. So these are called octets. When it comes to IP version 6, IP version 6 is separated by, I'll pull the pen back out here. Uh-oh. Okay, IP version 6 is separated by colons, as you can see here. And these colons are called hextets. These colons are called hextets. Take note, we have 1, 2, 3, 4, 5, 6, 7. We have 8 hextets. Okay, but Mr. Tandy, yeah, I totally understand that. We got the hextets, but how do we get to, how do we actually convert those numbers, right? How do those numbers get converted? What do we need to do to get these numbers, and how do we get these numbers? Okay, so let me show you how to do that. So what I want you to understand is that each one of these numbers, okay, or correction, each one of these characters in between the colons, they represent a bit string, some type of bits or hexadecimal. So what I want you to do, if you remember back in the last slide, let me back this up here just a quick second. In the last slide, 2 slides ago, I showed you this. We saw the decimal 0 through 15, and then the hexadecimal 0 through F, right? If you remember that, keep that in mind. So let me pull the pen back out here, because we talked about the characters. So what I'm going to do is I'm going to draw all the numbers out here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14, and 15. And let me just add the 0 here at the bottom. So we have a total of 16 numbers. But here's where it gets a little tricky, okay? Computers cannot read the double digits. They won't understand the double digits. So we're going to have to replace this. This needs to go. We got to get rid of the double digits. So what we're going to do is we're going to replace the 10 through 15. We're going to replace that with, let's see here. We already have A, B, C, D, E. I'm sorry. We're going to replace this with A. We're going to call this B. We're going to call this C, D, E, and F. We still have a total of 16 characters, but instead of using the double digit numbers, we're just going to replace them with A, B, C, D, E, and F. Okay, hopefully you guys see that. So 0 through 9, and then A, B, C, D, E, and F. Now, let's get this all set up, because we got to figure out how we got to the number 2. Because remember, there's still binary involved with this. How do we get to these binaries, right? There's some. This is a representation. This number. We see this in the physical space, right? Because we can actually see the number. We do IP config. We can actually see it. But how do we get to this? So let's take a look at that. Very similar to IP version 4, we got right out the bit stream, but a little bit different with each one of these characters. So what you're going to do here, and you can do this at home, I'm going to write some items out here. So I'm going to start here. I'm going to put the number 8. I'm going to put the number 4. I'm going to put the number 2. And I'm going to put the number 1. And what I'm going to do is I'm going to draw little lines right in here. And that's it. We're going to be inputting some numbers in here. So take note: 8, 9, 10, 11, 12, 13, 14, and 15, right? As we see the 15 numbers, 15 representation numbers. We still have 16, but it all equals up to 15. So how do we get to number 2? It's pretty simple. We see the number 2. We have a number 2 character here, so we're going to turn that light on. We're not using number 4. We're not going to use number 8. We're not going to use number 1. So guess what? They all are going to get zeros. So for this first number in binary, it is 0, 0, 1, and 0. So that is the binary representation for the number 2 for IP version 6. Okay. So let's take a look at 0. Now, folks, this one might be very, very tough. This one might be very, very hard. So let's see how hard this one is. So we have 0. Do you see any zeros here? The answer is no. So therefore, folks, in binary, this one's going to be 0, 0, 0, 0. Notice the bits. We get 4 bits and 4 bits here, right? 0 again. As you can see this, we have 0, 0, 0, and 0. The way I got that is because there's no representation of zeros. Now let's take a look at this number, number 1. How are we going to get to number 1? How do you think we're going to do that? So we have the number 1, so we're going to go ahead and turn that light on. Everything else is going to get zeros because we don't need them at all. Those lights don't need to be on. So the binary representation for for 1 is going to be 0, 0, 0, 1. All right, so I think you guys are getting the hang of that there. So let's go ahead and erase this out of the way here. And let's move on to the next hextet. Here we go. All right, so now we have 0 again. 0, 0, 0, 0. All right. Now we got some juicy stuff. Now we got the letter D. Okay. How are we going to get to D? Letter D. As we can see, the D, okay, is going to be in the 13th place of our numbers that we crossed out. If you remember, I said that the machine's not going to be able to read the double digits, so we got to replace those with the letters. So the D is going to be in the 13th position. And just to show you that again, let's go back here. Let's go back here to this graphic. All right, as you can see, here's number 13 right here. And there's the letter D, right? Now, the binary is already there, but act like you don't see that so we can act it out. Okay? Act like you don't see that there. All right. So let's find the letter D in binary. D is in David. So check it out. We need to get to 13. That's the number that we are trying to get. So let's see here. How are we going to do this? Number 13. Let's do some adding here. 8, 9, 10, 11, 12, and 13. Oop, I forgot to erase that other deal here. Let's get these out of the way. Sorry. Okay, going back. 13. 8 plus 4, 8, 9, 10, 11, 12, plus one more is 13. So we have 8 plus 4 plus 1 is 13. And this is going to be off. So, folks, the letter D, as in David, in this IP version 6 in binary is 1, 1, 0, 1. 1, 1, 0, 1. See that? All right, let's do letter B, as in bad boy, letter B. Let's pull out the eraser again. Let's get rid of this here so nobody can see that there. Okay. All right. Okay. Letter B. Let's figure this out in binary. How are we going to do this? It is going to be in the number 11 position. So we have 11, number 11. 8, 9, 10, 11, 12. Okay, nope, that's not going to work. We are going to use the number 8. So I know for sure that bit is going to be on. So we're just going to put a 1 there. 8, 9, 10, 11, 12. That's a little bit more than 11 by 1. So that bit is going to be off. We're not going to use that one. Trying to get to 11. 8 plus 2 is 10. Plus 1 more is 11. So in binary, for the letter B is 1, 0, 1, and 1. Let's do one more just for fun. This is number 8 in binary. So let's get rid of this one. I think you can probably see this already. Probably shouldn't have to write it down. I'm going to do it anyway so you can see it. Number 8 is this character here. So we're going to give that on. We're going to turn that one on. And this one's going to be off. These are going to be off. And this is going to be off. So in binary, number 8 is 1, 0, 0, and 0. So as you can see here, folks, every one of these characters gets 4 bits. So this is a 128-bit stream. It is very significant. Very significant. So there's a lot of items that you can do. This absolutely solves the problem with not having enough IP version 4 addresses on the planet. Going through IP version 6 definitely can get the job done. It's a whole lot easier. So if you're watching this video, you got some homework to do. I want you to email me. Send me an email. If you don't have my email, I will share my email with you. Make sure you send me this. I want you to send this to me in binary. I want the binary representations of these numbers. Okay, I want the binary representation of these numbers. Now, I know I added one here on accident, but that's okay. No big deal. I still want to see what these are in binary. Give those to me in binary. All right, that's going to conclude Module 5, and I'll see you on the next video.